Today we're going to have a look at one of the properties of image and a point that we should watch out for when using it so that we don't use them incorrectly in our proofs. Now, before we dive into the explanation, we need to familiarize ourselves with some terminology. We need to know what is a source and what is an image. Source and image are used when talking about mappings. For example, if you have a mapping that maps elements from a set A to set B, then we call A the source and B the image. Source and image are synonyms of domain and range. However, domain and range are used when talking about functions, and source and image are used when talking about mappings. So like we said, here A would be the source and B would be the image. And this would be a mapping from A to B. We also have specific notation to indicate that something is a source and something is an image. So f of A represents the image of set A, and f with the backward arrow of B represents the source of set B. So basically, if we have a mapping on some set A, we can call the image of A f of A instead of calling it B, like we did in the previous example. Now we can have a look at the property of an image. This property states that if we have some element x in some set A prime, then we can derive that f of x is an element of f of A prime. So this is the element after applying the mapping f on the element x. This is what we get. And this is the image of A prime, the set A prime. This is quite intuitive, since if you apply a mapping on some set, so if you have some set and you apply a mapping to it, let's call this A, let's call this the image of A, then the mapping applies to all the elements in A. So you can't leave one element out without applying the mapping to. So if we have something like this element maps to this one, and this element maps to also this one, then this is not a valid mapping. Not a valid mapping. And this is because the definition of a mapping is that you apply it to all the elements in that set. And as you can see, we haven't applied this because this is not mapped to any of these elements. So like we just talked about, we said that if we know that x is an element of some set A prime, then this implies that f of x is also an element of the image of A prime. However, what we need to watch out about is that the opposite does not hold. So that means that if we know that f of x is an element of the image of A prime, then from this we cannot deduce, like we do not know that x is an element of A prime. So this implies x is an element of A prime, and this doesn't hold. This is generally a bit harder to imagine. So let's have a look at an example that will help us visualize this. So let's see what we have here. We're going to define the set A. Let set A be the set of all integers. Set of all integers. Let the set A prime be the set of all natural numbers. All natural numbers. So that means that A prime is a subset, that's not the correct notation, is a subset of A. And now we're going to define a mapping. So let f be a mapping on A. Let f be a mapping on A such that f of x equals x squared. So basically f takes every element in A and squares it. Now you can see in the diagram we have A, and we can clearly see why A prime is a subset of A, because A is all the numbers 0, 1, 2, 3 onwards until infinity, and also -1, -2, -3 onwards until negative infinity. We have the image of A and we have the image of A prime. Now let's have a look at this number 1 in the image of A prime. So we know 1 is the image of some element x, and we know 1 is an element of f of A prime. So this is what we had before. So f of x is an element of f of A prime. So can we conclude that x has to be in A prime? Well, let's have a look. F just takes every element in A and squares it. So we have that 0 will be squared, which would be 0. We have 1, which would be squared, would be 1. We got 2, which would be squared, would be 4, but I didn't have space to write it down, so that doesn't matter. So it's mapped to something that's here. We have -1, that would be squared, and that would be mapped to 1. And -2, well, that would be also squared and it'll map to 4, but we don't have it here, so that's just going to be on top here. You can see that both 1 and -1 map to 1. So that proves our point. Just because this element is in this image of this set, that doesn't mean that the element, that the x that mapped to this element has to be also in the source. It could be outside the source. And this is a prime example of how this could happen. So let me just erase these extra lines so I can get rid of some of the clutter. So it would be something like this, that we have 1, which is in the set A prime, and -1, which is outside the set of A prime, but they both map to an element that's inside the image of A prime. But -1 is not in A prime, it's not in the source. So this is how you can think about it. Just remember this picture. Now I hope this helped clear up why this is the case. And if we just conclude it using some notation, we can say that x is an element of the set A prime is logically stronger to saying that f of x is an element of f of A prime. And this symbol basically means that if we have this, then we can imply this. However, if we have this, then we can't imply this. That's why it has a line here. So that's why we have a line here. That means that we can only go this way. And if it was both ways, then there will be no line. It will just be an equal sign, like that. That was it for today. Please leave a comment down below with any questions that I could have a look at. And thank you for watching.